All right, guys. Looking at exercise 6B, this is question 4. I've got a question about. I'm going to start off this one with a bit of revision in a way. Piece of cardboard consists of a parallelogram with two identical squares. So, all right, what we're going to do, same as we talked about at school, we're going to have area 1 there, and I'll call this area 2 and area 3. So there are our three areas, and in this case, our area total is going to be area 1 minus, oh, that's an equal sign, minus area 2 and area 3, okay, because they're the two we want to take out because we only want the shaded area. I hope everyone's okay with that. Now, this actually says that they're two identical squares, so that means that area 2 and area 3 are exactly the same. So area 2 equals area 3, okay? So what I can actually do up here is, instead of having that, I can have area 1 minus 2 times area 2, because we have two of them that are the same, okay, which makes our life a lot easier. Now I will go on and go, okay, well, with area 2, it's going to be the sides squared, and the side lengths in this are 2 centimetres. So I'm going to do that, which is going to give us 4 square centimetres, okay? Which means if I just drag this across a bit, I don't know why I put it so far to the left, but anyway, if I drag that across a bit, I'm going to have area 1 minus 2 times 4 centimetres squared, which means area 1 minus 8 centimetres squared. Now we get on to area 1. Now, area 1 is a parallelogram. I hate to say this, guys, but the area of a parallelogram is not on your formula sheet. If I just duck over to my example, to my stuff here, the HSC data sheet, you can see that here is your data sheet for your HSC. Here is the stuff on area, and hopefully you'll be able to go, oh, that is the area of a sector. That is the area of a trapezium. And that is the trapezoidal rule, which we will be doing later on. But you've got those formulas on here, okay? So that's great. Unfortunately, it doesn't give us the area for a parallelogram. Now, the reason I said unfortunate a couple of seconds ago is because the reason they don't put it on there, unfortunately, is because it's the same as a rectangle. It is just a rectangle that's sort of leaning over. It doesn't have the 90-degree corners, okay? But the area for a parallelogram is base times height. The only difference is, much like a triangle, it has to be the perpendicular height. So they've given us the perpendicular height, not the height of it leaning over. So the height of it leaning over, the length of that would be longer than 8 centimetres, but we don't care about that, Dean. It's only the height that we care about, which is the height from the base to the top. So it's the perpendicular height. So in our particular case, we're going to have area 1. So I'll just box that off a bit. Area 1 equals base times height. Our base is 12, and our perpendicular height is 8. So we've got 12 times 8, which gives us 96 square centimetres. So we can sub that in over here, and we get 96 square centimetres minus 8 square centimetres gives us an answer of 88 square centimetres. So that's it. It's the same process, and I have a feeling that the student who sent this to me, that it may have been the fact that it was a parallelogram that was tripping them up. But parallelogram, same formula as a rectangle. You just got to make sure you've got the perpendicular height, not the length of that side. Now, I guarantee the next question is going to be, well, what if I got given the length of that side? So, well, that's great. You would have to work out what the perpendicular height is, and you might have to use Pythagoras. But to be honest, in most questions, they're not going to give you that. That's not what we're trying to do. Okay, so we'll give you the perpendicular height, and we'll give you the base, and you can just use the area formula that we've got here, and you're golden.